Yesterday, I don't think I explained things very well, and I got a lot of confused students, and it bothers me, okay? And it's my fault, okay? Because I was rushing. So as I said, this is one of the most difficult topic around, and I decided I will not rush anymore, okay? First thing I want to clarify, yesterday, as I said, I did not explain this clearly, and I'm going to do it just to clarify some matters, okay? So we did this example yesterday. Okay, so what I'm trying to show you is this. So if we know that over here, this is our geometric centroid. Okay, so we are going to find the first moment of area about the z-axis for point B. Okay, we are going to determine, and by using the rules that we have stated. So one of the rules that we have stated is the geometric centroid is the datum. Okay, and we want to find B. Okay, and we know the analysis starts from Y max, so this is the analysis direction. We are aware that the distance from here to here is equal to 0.35. And we are also aware the remainder of the distance is 0.65. So let's get the information straight first, okay? So the distance from the datum to here is equal to 0.35. Okay, that is, so 0.35 plus by 0.30 is equal to 0.65. Okay, so let's set. So we are going to analyze based on the rules. This is the area that we are going to find the first moment of area. That is the area of consideration. Okay. So we are going to apply QZ at point B. So this will be equal to width, depth, y bar. Because the axis of interest is ZZ, this is our width, and this over here is our depth. Okay. So this will be equal to 2. The width is equal to 0.02. The depth is equal to 0.3. And the y bar is equal to what? So the y bar is equal to 0.0 is equal to 0.065. Yes. Oh yeah. Yeah. In a rush again. You know what? Let's do all this in millimeters, okay? So this is in 35 millimeters. This is 65 millimeters. This is 30 millimeters. And then finally down here is 35 millimeters. Okay. So we are going to do y bar, which is equal to 0.065 minus, okay, so we can do 0.065 minus by 0.03 divided by 2. Okay. So this is the case, what we have over here is equal to 0.065 minus by 0.03 divided by 2. No, 0.03 divided by 2. 0.065 minus 10 times by 0.03 times by 0.02 times by 2, we get 60 times 10 to the power minus 6. Meter squared or meter cube. Or you can 0.065, hold on. You can also, okay, you can also do this, okay? You can do 2 multiplied by the same thing. And if you use the equation that we derived, this will be equal to 0.065 plus by 0.035, and then the whole thing multiplied by half, and the answer will be the same. Okay. So if we do that, 0.065 plus by 0.035 times by 0.5 times by 0.03, Eugene. Can you put a 03 over here? Okay. So 0.065 plus by 0.035 times by 0.5 times by 0.03 times by 0.02 times by 2, you get 60 times 10 to the power minus 6 also. So this over here is your width. This over here is your depth. This over here is your y bar. Likewise, this over here is your width. This over here is your depth. This equation over here is also your y bar. It's the same thing. Okay. So the value that we get is 60 times 10 to the power 3. Now, what if you forget the rules? Okay, and we tend to. Okay, so another way of doing this, I'll let you finish copying first. Anyone, any question before this? Are we okay? Clearer now? Yes. So y bar is the distance from here to here. This is your y bar. Does that make sense? Okay, that is your y bar. Okay. I want you to clarify. I'm not going to rush. Okay, anything that you're not sure, I want to answer it, because if this stage we are having issue, then the future stages will be in a bit of trouble. Yes. When you have to integrate what? So you only integrate when you want to find the forces acting on a specific section. Okay? If you don't need to find the force acting on a specific section, you don't need to integrate. Okay? Now, what if now, okay, you don't want to apply the rules, okay, and you want to consider this entire area? Let me, you still have to partition it. What if you want to consider this entire area? Okay. You can do that. Okay, so I'm going to show to you the answer is exactly the same. Yesterday, I made a mistake because I got confused where the datum was. Okay, still the same thing. The geometric datum is at the centroid. Okay, now the first moment of area, anything at the top will be positive, and anything at the bottom will be negative. Okay, so I'm going to call this our flange, and I'm going to call this top web, and I'm going to call this bottom web. Okay, as I said, the answers should be the same. Okay. So QZ at point B can be equal to QZ at the top plus for QZ at the top web plus by QZ, sorry, not web, QZ for the top, for the flange plus by QZ for the top web, and then we're going to minus QZ for the bottom web. And the answer should be the same. Okay, yesterday was not the same. As I say, I made some mistake. So QZ for the top, for the flange. So the width is 0.16. The depth is equal to 0.02. The Y bar will be equal, so we know the distance from here to here, which is equal to 35. So it's equal to 0.035 minus by 0.02 divided by 2. Okay. So this will get you 0.035 minus by 0.02 divided by 2 times by 0.02 times by 0.16. We should get 80 times 10 to the power minus 6. The next thing that we're going to find, any questions why 0.03? Okay, so 0.035 is over there. Okay, so what we want to find is we want to find the Y bar over here, right? And then the distance from here to here is equal to 0.02 divided by 2. Very clear? So the next thing that we're going to identify is we are going to find the QZ, and we are going to look for the top web. Okay. So we have to include 2 because of left and right. The width is equal to 0.02. The depth is equal to 0.015. And the Y bar will be equal to 0.015 divided by 2. Why that's the case? Because the distance from here to here is 15 millimeters. Okay. So the outcome from this is equal to 0.015 divided by 2 times by 0.02 times by 2. You get 4.5 times 10 to the power minus 6. Okay, so 4.5. And then finally, we are going to do our QZ, and this will be the bottom web. Now, the bottom web is only up to a distance of 0.035. Okay, that's our bottom. So the distance from here to here is 0.035. Okay, so we multiply by 2. Okay, the width is 0.02. The distance from the datum to the point of interest at point B is 0.035. Multiplied by 0.035 divided by 2 again. Okay. So 0.035 times by 0.035 divided by 2 times by 2 times by 0.02 is equal to 24.5. So finally, the QZ at point B will be equal to 80 times 10 to the power minus 6 plus by 4.5 times 10 to the power minus 6 minus by 24.5 times 10 to the power minus 6. This in turn will be equal to 40 power minus 6 plus by 4.5 power minus 6 minus by 24.5 power minus 6. The answer is equal to 60 times 10 to the power minus 6. It's exactly the same. Are we clear? Like what I said yesterday, This one has less component. Okay. The other one that you see, you have to calculate so many terms. Okay. So apply what I teach, it will ease your pain. Are we clear? Okay, but you have to remember, what do you have to remember is what? The centroid is the datum, and the analysis starts from where? Y max. Are we clear? Then you'll be fine. But as you can see, the answer is exactly the same for today. Okay. Better now? The only thing that you have to be aware, as I said, when you do on the bottom, you have to ensure that where you take your datum from. That's the only point. Okay. Right. So any questions so far? Well, okay. I'm going to start the next problem again. And it was not very clear because I have a lot of students asking me questions after that. And I realized that, hey, I did not explain something properly. Okay. We're going to continue with this example over here.